This is part 5 of section 1.4. Step functions and the greatest integer function. Step functions are defined in pieces, and when they are graphed, they look like literal steps. Just as a quick example, looks like this. Okay? If you're using a graphing calculator, you want to check your settings to make sure that you're not graphing in connected mode. You want to change it to dot mode. If you do it in connected mode and you're using it that way, what it's going to do is draw a line in each of these areas, which if there's a line here to here, then you're not passing a vertical line test, which means you're not dealing with a function, and your graph is completely wrong. So make sure that you're doing it that way. Okay. So one of the most common step function is called the greatest integer function. And it is denoted with this double bracket right here. Or you can also see it as INTX. This is the way the book uses it. This is the way most graphing calculators use it. But it's also called the floor function. This is a concept that appears in multiple areas. It comes up in physics, it comes up in computer science, and they all kind of have their own individual notations and vocabulary, even though it's all the same idea. Now, what this function is, so if you're asked to find the greatest integer of x, then that is the largest integer, which means no fractions, no decimal, the largest integer less than or equal to x. So for an example, if I want to find the greatest integer of 2, then I'm looking for the largest integer that is either less than 2 or is equal to 2. And since 2 is an integer, the greatest integer is 2. Okay? If I want to find the greatest integer of 2.3, the largest whole number, I say whole number, integers are whole numbers that allow signs, so positive or negatives. I want the largest one that is either equal to 2.3, and 2.3 is not an integer, so that doesn't work, or the largest one, like if we go down, the first integer we hit. So if I'm looking at a number line, and I have 2, and I have 3, 2.3 is about right here. I go down until I hit the first integer, so that is 2. If I want to find the greatest integer of 2.99999, that is right here. Even though it's awfully close to 3, I still always go down, and my answer is the first one I hit, which is 2. It's not a difficult concept, but when you're asked to find the greatest integer of a negative number, this is the one that always messes us up because we think it's easy and we just randomly write down an answer because we think it's obvious, and often we've messed up our signs. So make sure that you're thinking about it as if it were on a number line. Negative 1.1 is between negative 2 and negative 1. Negative 1.1 would be about right there. And we always go down until we hit the first integer. So that is negative 2. Now, if we end up graphing this, you do end up with a graph like this. Now notice right here, if I plug in 2, 1, 2, it exists right there. The answer to f of 2 is 2. F of 2.3, which would be right here, go up, is still 2. 2.999 is still right here, still 2. Negative 1.1, which would be about right here, it is negative 2. Okay? So that's all the basic stuff. Now there is more to this chapter, and basically I'm going to be just talking very generally, I have trouble with that word again, let me try it again. Generally talking about some very basic functions. These are ones that you've encountered before, I am sure. I am including these. Basically, these are the pictures that are available on pages 70 and 71 in your textbook. You can access your e-text either through MyMathLab. There is a link on the left-hand side. I have also provided a link on the left-hand side in your Blackboard course. You should see MyMathLab e-text, or just e-text. I can't remember how I labeled it. But you can go to these pages in your textbook and you will see the same images. Okay? You want to become very familiar with all of these graphs, not because it is important that you can spit these out automatically, but because later on, you're going to want to be able to look at a formula and have a basic gut idea of what your graph should probably basically look like. Okay? This chapter is not about just entering equations into your graphing calculator and spitting out the answer. Work towards understanding. Okay? So several of these we've talked about, but the main ones we have here is we have the constant function. Your domain, it goes from negative infinity to positive infinity. Your range, you only get a single y value out of this, and it is going to be whatever this number is. Since you only have a single value, that's why it's in braces. It's not interval notation, it's just one single number. It is the constant function, so you would hope that it's constant. And it is an even function because if you folded it along the y-axis, you do have y-axis symmetry. Here we have the identity function, which we've also talked about earlier. It exists everywhere on x. It exists everywhere on y. So that's why our domain and range are all real numbers. This goes up everywhere, so it is increasing everywhere. And it is symmetric about the origin, so it is an odd function. Okay? And then very quickly, just talking about the rest of these, I don't think you're going to have any trouble understanding what these things are telling you. We have the x squared function, which is a parabola, and it is even, as you would expect, with an even exponent there. You have the general cubic equation, which looks like this. And it is odd function, as you would expect, with an odd exponent there. We have the absolute value function, which comes to a strong point, which is one of the few points we have like that, one of the few basic graphs that we have like that. And actually, when things come to a point, that can cause some problems in calculus, so you may want to just sort of keep that in mind. If you look in your textbook, you will see where they define the absolute value function as a piecewise function. But your domain, you can plug in any value of x, but when you take the absolute value, you will only get a positive answer or 0. Your graph is going down here and going up here, and it is even because you can fold on the y-axis and it matches up. Now, square root function looks like this. It is essentially half of the square function. It's just turned on its side. And our domain is 0 to infinity because we can only take a square root of a positive number or 0. That's why it doesn't exist over here. When we take a square root, we only get positive numbers or 0, which is why my graph doesn't exist down here. It's increasing everywhere, and it has no symmetry. Okay. We have the cube root function, which similarly to this, where you turn it on its side, if you turn the cube root function on its side, you get this. Okay. Now, since we are allowed to take cube roots or any odd root of a negative number, we don't have any restrictions on the domain or range. And it is an odd function. We have the reciprocal function, which is 1 over x. And notice right here that we don't have a graph. That line there And actually this line right here, the dotted line, those are called asymptotes. That's going to be important later. Okay. The reciprocal square function, so instead of just x, we're going to have x squared. Now think about it. When we square something, it makes our answer positive. And it essentially took this and flipped it up that way. Okay? And again, we have the same asymptotes. Okay? We have our rational power functions. So we have a fractional exponent there, but not 1/3, which would be the cube root, and it's not 1/2, which would be the square root function. Here we have 3/2, and here we have 2/3. The difference between these two graphs is whether or not your denominator is even or if it's odd. If your denominator of your exponent is even, you're going to exist on this side. Notice it exists on that side for here. Okay. And then if your denominator is odd, it's going to look like this. And then here we have the greatest integer function, which we have also already talked about. Now, this last bit, these library functions, honestly is not that critical to section 1.4, but we will be using it in section 1.5.